but we got this. So let's go over the test, question by question. We're recording now, so if you need to see this again, like later tonight, tomorrow, whenever you're doing the revisions, if you have mistakes you need to fix, get out a piece of graph paper. That's everybody. Get out a piece of graph paper, and let's fix these mistakes. Antonella? Thank you. Today's lunch is corn dogs, mac and cheese. I'll pause my recording because we don't need to waste time on lunch count. Remember that we have our new student here named Nolan. So if you see him in the hallway, just say hi. Make sure if he looks lost, you offer some assistance. He has his schedule, but as you guys probably can't remember at this point, that schedule, even to look at it listed out, is confusing, right? It's like a lot. Layla's like, yeah, it was.
What's his advisory?
I am. So, I'm his advisor. If ever you need anything or need a teacher to, help out with, wait, where is Nolan actually supposed to go, right? Come see me. Some of you need the motivation from the dude wagging his finger at you. So, do your work. Go ahead. We should give him a name. Patrick Practice? I don't know. So, we need to go over the mini mastery first before we get into the lesson of doing that stuff that I still want to do from last week. We may slightly tweak things for this week. As you guys know, it's only a 3-day week. But the homework I would like you to do is not up here yet. It's what was on the screen, so 624 for tonight. Should be the homework that we're trying. So guys, I have all my work showing out on here because I want to be able to show it to you guys and let it soak in of okay, what did he do? But then if you're confused about something, please ask. So for number 1A, the answer, and then we'll go over how to get there. The answer that you should get to is that x equals 0. How we get there is after combining like terms. Guys, our first step always should be separated down the middle, so on the left side and then separately on the right side, we're combining like terms. So -1, those make -2, but then also +2 can go with that. And the right side's constants. What happens with a -2 and a +2? They cancel out and make 0. So we're literally back at our make zeros step. I'm going to use a different color just to make sure we all know what's going on. +5, and guys, a -5 is a -5. So what happens with a +5 and a -5? They cancel out. They make 0. What happens with a -2x and a +2x? They cancel out. Guys, math teachers, we think we're clever when we're writing problems. And we make all these different things happen. So the only thing we have left is 6x on this side and 0 on this side, which is where some of you got stuck. But guys, and I did not write this out yet on purpose. What do I do to get rid of this 6 that is multiplied by the x? We divide by 6. And can I take 0 pieces of candy and divide them to my 6 friends? Yeah, but everyone is sad. Because we all have 0 pieces of candy. But I can do this. What some of you got confused about is I cannot divide by 0, meaning I can't put a 0 on bottom. But I can have a 0 on top and do division. If I have no pizzas that I divide to everyone at my house, we all have no pizza. But if I buy 6 pizzas and try to divide them to 0 people, that doesn't make sense. Division by 0 does not make sense. But dividing with 0 on top does. So does this make sense? What questions do you have? I know which ones of us got this almost right. I know which ones of us got this very not right. Please ask questions. So then over here, and guys, grab highlighters if you want. If you want to highlight right now, even though this test is done, you can still highlight on this paper. 5x and negative x makes my 4x. Minus 1 has no one to team up with. 11 and negative 2x, no one to team up with.
Excuse this interruption, Phoenix. Can I please have Samaje Story and Madison Brockrat to the office, please? Thank you.
This was a huge missed step. If you have negative or minus 2x, what is the inverse operation? Add 2x. If you did minus 2x right here, I probably drew an arrow and a question mark. Kind of me asking, wait, why did you do this? You probably also have an arrow from me pointed to that. That goes with the 2x. If you want to copy this just for right now, then you'll just need to do it. Did you get a copy of the original? Oh, you do have the original. So what you'll want to do is I haven't passed them out yet, but you'll want to do the follow-up since you missed that, but you should be writing it along with us. So do it with us right now. Guys, as always, the habit that you should be used to by now is I have a follow-up for you. You'll get this afterwards because I'm doing all of these corrections for you. Right? I've realized that it's better if we do our corrections together and then try the skill again. Antonella, you good? Because I see that calculator. You need help with anything? Okay. So when we add 2x on both sides, we now get 6x minus 1 equals 11. That's not the only option that you could have taken. If you subtracted 4x from both sides, you would just end up with like negative 6x over here. So remember, there are multiple options. I might make a video later of like the alternative ways to solve these problems. But this is, in my mind, what I think is best because the variable stays positive. How do I get rid of a minus 1? Plus 1 on both sides. Guys, I was very intentional as I made this answer key this weekend to use my color coding to say I'm doing that on both sides. And now I'm back to 6x equals 12. What do I do to deal with that 6x? Oh, hey, look, the same. Hey, we had 6x over here. Oh, that's so coincidental. Divide by 6. We get x equals 2. Questions on that one? Guys, you should be writing this with me. If you did not get this question right, you should have these steps written down on your graph paper now. So I'm going to start asking those of you who I don't see pencils moving. And you can go back to the video, right? If you miss it right now, you can go back to the video later. We're looking only at A first, so actually I'm going to cover up B because B has a lot going on. In A, one trapdoor was, do you have 3x here? If not, you forgot to distribute both of these, which was probably if you forgot the arrows, these arrows on top. I forgot to draw my arrowheads, but 3 times 4 is 12. 3 times x is 3x. Any questions on my first step here? Just my first step. Guys, I'm going slower than I would like to, but I'm trying to make sure you have time for questions. Then my advice that I gave you, not the only right way, but if I have a smaller x, like 1x, and a bigger one, it's easier to take the smaller one away. So if I minus x from both sides, now I get 12 plus 2x equals 6. This is where people goofed up. If you then took away 6, you did not pick sides. And I probably wrote on your paper, pick sides. Because if you push everything to the same side, like here, I'll give you the example of what I saw people do. I saw people subtract 6 from both sides here, and then they had 6 plus 2x equals 0. which is not wrong. But now it's like, wait, what do I do now? I've got both of these on the same side. Well, you could still minus 6, right, to get this off of this side. Or if we had picked sides and said, oh, this is our variable side, so this will be the constant side, get rid of this 12. How do we do that? Subtract 12, because this will make 0. So we subtract 12. We get 2 times x equals negative 6. And then we divide by 2, making x equal to negative 3. Questions? Because I need more coffee. My morning has been very busy. All right, then start looking at B. If you don't have questions on A, you can start looking at B and trying to see what did you goof up. Remember, there are multiple ways to do this. I just wrote down what I think is the best way. We distribute, so 4 times 2 is 8. 4 times negative x, negative 4x, or you can say minus 4x. Guys, you gotta tell me right here, so with everything I have covered up, only with what you can see, do you have questions of how I got that? I distributed the multiplication. Then what did I do? Put 3 with 8, 3x with negative x. What do we call that? Combine like terms. So this 11 was from 3 plus 8. This 2x was from 3x plus negative x. Some of you chose to do that in the first step. You're allowed to. It's just a little dangerous. Then, we always said if we have negatives and positives, get rid of those negatives. No one likes negative people. So how do I get rid of negative 4x? Add 4x on both sides. Notice how I just try to keep my equals like real lined up. You can also have that dotted line down the middle if you want. Now I have 11 equal to 6x, right? Because we added 2x and 4x. And I still have my minus 7 over here. So now my variable has gotten together on the right-hand side. So this is, I picked sides kind of like accidentally or without thinking about it. My right side is my variable side. Get rid of this minus 7 by adding 7. Then we will have 18 equal to 6x. What would x be? 3. Guys, I am telling you, your follow-up is very, very, very similar. So if you have questions now, ask them. If you're not comfortable to ask it now, you can bring it to me later. Like, make yourself a little note right now if you need. But are there any remaining questions from the front? Because the back is different, right? The back, we kind of change gears. Any remaining questions from all of this? And yes, this is why I rewrite my tests every year. Sure, somebody could go back and watch this video next year, but I highly doubt they will. If you have that much effort, you probably know the math. No questions from the front? Did we all find at least one like silly mistake that we're like, oh, why'd I do that? You added instead of subtracted, or put together things you couldn't put together, or forgot to distribute. You got to watch out for those silly mistakes. And the best way is to practice. That's the best way to find what mistakes we make and avoid them in the future, is to practice. Guys, I realized this morning, like, I had made a mistake on my answer key. And, like, I didn't mess up your grading. Don't worry. But, like, everybody makes mistakes. It's all about the more we practice, the less mistakes we make. Let's talk about boundary points. When we go to graph an inequality, we make, I'm going to give you an example for any inequality. We make a number line. right? That's like step one. We place the number that we care about, not x. This should be a number, right? The number that we have figured out. Then, and I'm going to use a different color to make it like super obvious, we put a circle. It has to be a circle. It cannot just be a tiny point. You cannot leave just a gap on the number line. You have to put a circle on the number line. And then you figure out, is it shaded or not? And do I shade? Guys, we are shading. We're not drawing arrows. Like, we have to shade. So we can, like, squiggly line. But we have to show some obvious, like, it's going this direction. And then we either run into the arrow on the end, place an arrow on the end of our shading, or both. And some of you shade, like, a lot. Like, you kind of shade in solidly. And that's fine, but we have to have it obviously shaded. So this would be showing that x, my range for x, this would be showing x is greater than whatever number I placed on my number line, right? So some of you, I wrote direction, question mark, on your paper. Guys, look up at the screen. Look up at the screen. To the right of a number is bigger than. Or if I turn my number line vertically, above is bigger than, greater than, more than. Below the number, or to the negative direction, or to the more negative, like bigger negative, is less. So if you get told, here I'll use a different color, if you get told that your x is less than a number, remember the gator's eating the bigger thing, so this means x is less than the number, we'd be shading to the left. Less than goes to the left. If x is less than. That's kind of a way you can remember it. If x is less than, it's going less. So there's your answers for A and B for number 3. Any questions on those? See my obvious circles? Obviously shaded in or not shaded in. This one for A is shaded in because or equal to. Or equal to tells me, oh yeah, shade it. If it doesn't have the or equal to, we do not shade in the boundary point. Kylie?
I have something on my paper that says we shade ...
Yeah, so I don't think you had shading. I think you drew like an arrow or something. We got a shade on our number line. Like really show, like get a highlighter or something. Like you can use your pencil, but like some people like to like change colors, kind of like I did here. And then in 4 was combining 1, 2, and 3, right? Number 4 has us doing stuff on both sides. So here, let's only look at A first. There are multiple options, but since I have a negative variable, remember that negative, that minus goes with it. Since I have a negative variable, I'm going to choose the option where I get rid of the negative. So I add 2x to both sides. Then since I've chosen left to be my variable side, I add 3 on both sides. If 5x is less than 5, we divide by 5 and get x is less than 1. The other option I saw a few of you take, which was sweet, for number B, 4/5, and we did this one in class, but it's still kind of confusing. 4/5 is a fraction, but could we make it a decimal? Yeah, you got a calculator, right? 4/5 is actually the decimal 0.8x. So a couple of you said, well, if I make this 0.8 times x, or like 8/10 times x, I can divide by 0.8. And we could. You can. This is totally fine. X is greater than or equal to, I throw that in my calculator, it's 10. But what I showed you in class, and actually the better way, really, in my opinion, especially because then I can say, uno gigante? Close? Getting better? Yeah? If I multiply by the reciprocal, the refliprical, we sometimes call it, I will make a giant 1, but my art skills are bad and I can't draw a big boxy 1. Sorry, this looks weird. But this is a giant 1. 5 times 4 makes 20. 4 times 5 makes 20. I thought about doing the whole I told you so thing and pulling up my video from class when we did this together, but I decided not to. But now I said it, so whatever. We do the math on the right-hand side, and we get x is greater than or equal to 10. When I made my answer key, I forgot to shade this dot in. And then I started grading, and I was like, whoops, this has or equal. I need to shade this in. Questions? Now, I will say on the follow-up, you do not have one like B with the fraction, but on the end of chapter, and maybe even before that, you will see that again. We will have to do that again. These should all get attached together. Look at what this says at the very top of it. And it's got a hole punch, so my bad. But to best complete this follow-up, you should have the original mastery and the revisions that we all just did together. You should have that as reference. Everybody's getting one of these, even if you maybe didn't make any mistakes. I don't know if that's any of us, though. I don't know if any of us had a perfect test. Put your name on your follow-up right now. We're having big issues with missing names. Put your name on your follow-up right now.
I think you gave them
Oh.
yeah.
I'm double laughing. Here's my advice. Take the new paper I just gave you, the revisions you just did, the original mastery, and go staple all of it together right now. I got a stapler over here too. You want these things to be together in your binder. No, we will actually check 623 tomorrow. Good question, though, because I'm going to go back to that slide. You don't need to give me 623 till tomorrow. So, if you have it today and you're super confident, just hang on to it. I know some people thought it was going to be due today. I put it here because I had told people, hey, you can turn that in on Monday. And really, that is like a can thing. I would put your follow-up on top if I was you. Just so you know that, like, oh, I need to do this, so it doesn't look like something you already did. And then you need graph paper. At least I think, I can't remember what I put on the 624, but I do not think we're there yet. We shade the solution. So the arrow that you're drawing, that is not what we do. We shade. So you shade it in the boundary point, but then we shade on the number line. Like because you're shading where X is allowed to be. Okay. Right? Too many arrows would get too complicated. Okay. All right, graph paper. Like probably maybe fresh, unless you have some graph paper left from last week. Yeah, but we're actually going to pick up a couple problems from 623 first. guys, if you do not have 623 done yet, please do it tonight. Like, I know we just gave you 624, but 623 is due tomorrow. Like, let's stop this game of, like, acting like you can't do it and then just, like, bringing it to class. Like, you got to put in effort. Okay? So it's a short week. You're not going to be asked to do all that much. Then you got Thursday, Friday as discovery days. Even if you're behind, you're coming in to catch up, and that's good. Like, that's a really good thing. So please do 623. You will never get better at this stuff if you don't practice on your own. So Jenny is really confused. They've been working with algebra mats, and Jenny got to this. And Jenny tells her group, we can't do this. And her group is like, Jenny, stop saying you can't do something. Mr. Hudson just yelled at us about that. And then Jenny's like, well, I don't think Mr. Hudson ever really yells. I get disappointed. Okay. So Jenny's like, all right, what can I do? I don't know what to do. Anyone got any help for Jenny? Aiden, if you want to jump in, I wanted to give you a second to think, but then John shot his hand up, and I think he distracted you. No. On your paper, write down a 77, just so you know what problem we're doing. And then write down 2x equals 3. This is the problem Jenny and her group are looking at. 2 times the value of x equals 3. So guys, I will tell you on the follow-up, unless I've goofed up, most of those answers should come out to be whole numbers. I don't want to say all of them because I want to double check it. I made it kind of quickly this morning. I want to double check my work, but now we're going to switch gears a little bit. John, do you know what I mean? Because your hand was the first one up. And I'm not using cards right now because this is new.
Are we doing it to make it...
We're trying to figure out what x is.
Bella, to the office, please. Leo, please come to the office. Thank you.
And Jenny is thinking back to last week when we made like nice groups that could all like same in each group.
Couldn't we, since x can be anything, can't you do the division?
Yeah, can I do the division and look at just what 1x is? I think I can. Just like Thomas the Tank Engine, I think I can. Is that still a thing or
Yes,
no?
it is, but I don't know.
Oh! Do you guys know Daniel Tiger?
Yes, I do.
Okay, see, I wondered this. I was hanging out with my nephew this weekend, and we put on Daniel Tiger, and that's like his best thing ever. So I can reference Daniel Tiger stuff, and you'll know what I'm talking about. Okay. Like, crap, what was it? When things seem bad, turn it around and find something good. No? Okay. I was singing that to my nephew Finn. All right, so can I divide? Can I do 3 divided by 2? Yeah, we can do this. So wait, when Jenny said I can't do this, get that out of here.
She can't do anything.
Quit. No, she can do anything. She just has to have that mindset of I can do it. Now guys, here's the thing. What does Mr. Hudson like better, fractions or decimals? Fractions. So I just wrote down a decimal, but you could also leave your answer as x equals 3 over 2. You could also make your answer x equals 1 and 1/2 in mixed number form. All of those are correct. So now we're going to start to see x not necessarily being a whole number, and that's okay. Are most things in life whole numbers? No. I mean, once you start going and doing your own shopping, unless you like go to a dollar store where it's like everything's $1, $2, $3, $4, like.
Wait, not anymore. This
Right, well, now it's different, right? So, like, most things are not entire dollars. Questions on this? So we can still divide even if it's not nice. All right, switching gears. Let's talk about some word problems. So I feel like we've been shying away from word problems. Whoa, hate's a really strong word there, bro.
Well, it's true.
All right, check it out. Read along with me. Maggie's mom agrees to let Maggie buy small gifts for some of her friends. Each gift costs $4. If you're talking at the same time as me, you are not helping. If you want to read, just like ask me if you can read. Maggie's mom gave her a budget of $19. Now wait, what's a budget? Who can tell us what a budget? Layla?
It's like a certain amount of money. Like my mom, for example, had a budget on how she wanted to buy, like a certain price range. Like that's what a budget is like. Our budget for this project is like $25,000.
So should we be at that amount of money, below that amount, or over that amount?
Lower that.
Definitely not over, Layla says. So this budget, could Maggie spend all of the $19?
Why couldn't she make it 20?
Hey, John, chill. There's a reason. Could Maggie spend the $19? Yes. Could she spend only like 10 of it? Yes. On your paper, what I want you to write is spend less than... Wait, is she allowed to spend the 19? So less than or equal to 19. Spend less than or equal to 19. Yeah, so that's a really good point that I'm glad you brought up. When we're solving and doing the work, it's okay if we don't put the labels on. And the reason that I'm going to leave them off is I don't want this to look more complicated, but you're right. Like, labels are always a good thing. At the answer, we need to figure out what label the answer gets. But here our answer is actually going to ask us how many gifts. So the label on our answer is going to be amount of gifts, actually. John, question?
Not a question.
Then not a hand.
Should I start it out?
You just answered stuff already. I gotta talk with multiple people.
Okay.
Do we, Farah, do we know how many gifts she's buying? No. Do we know how much each gift costs? Yes. So what we know is every gift, hold up, is going to cost 4 times, what variable could we use for gifts? G. Sure, 4 times G for the amount of gifts.
Wait, but that's doing 4 times gifts.
Correct. The amount of gifts. It's $4 per gift. See, I think all the talking you've been doing has gotten your brain like too far ahead.
But you can't get 4 gifts. Because
That's not what I'm saying. The gifts are $4. This is the dollar amount, but this is the amount of gifts. So what you might need to write down is G equals gifts, like the number of gifts. How many she is getting.
it was the 4 that confused me because there
The
wasn't.
4 isn't the problem.
There wasn't like a money.
Right. But then she has to pay something else. Man, if you're not a Prime member, man, Prime needs to like give me some money. So Franco, if that's an extra shipping fee, is that going to add or subtract to what I spend? It's going to add, man, plus 7. That still is going to need to be less than or equal to 19. Work with your team to figure out how many gifts she's allowed to buy. Ah, hold up. So, this, I maybe didn't say this well enough. That $7 shipping is just total, no matter how many gifts she bought. It doesn't matter how many. She just pays $7, right? A flat shipping rate. So, first thing that she has to do is take that $7 out of her budget. Layla, what do I do first? Yeah, you just kind of started playing with it.
And then I got 12, and then I added 7 because she's buying everything individually.
You're right. So you kind of did 5D process. Yeah, you kind of did like guess and check. If I wasn't doing guess and check, though, what, Lucas, could I do first?
You do -7 on both sides.
Pay the shipping, right? When we pay the shipping, that's going to take away $7 from how much I have that I can spend. So now I have 4 times G is less than or equal to 12. And Layla kind of already told us how this is going to work. But what do we do to get there? Anybody, what would we do here? Divide. Wait, divide what?
4.
Divide by 4.
Oh, yeah, but you get 3.
John, your brain is glitching out today. You're not listening to what I'm asking. You're just shouting out whatever numbers you want. G is less than or equal to 3. But what label would go on that? It's not dollars. What was G finding for us? Gifts. The other label that we could probably put on that is friends that she will still have after the party, because if I'm joking, but if people show up and they don't get a gift, they're gonna be sad. People show up and they don't get a gift. That's not good.
I show up here every single day and I don't get a
Your gift is knowledge, Antonella.
gift is not getting
Questions. Questions. We set up. Please stop talking, especially if you understand what you're doing. We set up the amount of dollars it's going to cost for gifts, because it was $4 for each of them, times G amount of them. Then the amount that we're spending also has to include our shipping, and all of that we spend has to be less than or equal to 19. We spend the shipping, right? We take away 7, meaning I have $12 left for my gifts. I divide by 4 because each of them costs 4, and I get that I can buy 3 gifts, or I could buy 2, or I could just buy 1. But I can't buy 4, right? Cannot buy 4, that will not work. We are out of time. So, hey, hold up. 623. Hey, stop. Hold on. Guys, we gotta stop with like, oh, the teacher's talking about who cares, I'm gonna multitask. Stop. Look at me. 623 is due tomorrow. The follow-up should be your next priority. 624, I'm not worried about. We didn't even get into that lesson today. So you have it. If you want to work on it, great. But there is a class example on the front. Don't do that. We'll do that together. But your follow-up is what I'm more concerned about. What does it say at the top of your follow-up? When is it due? It's due by Wednesday, because then you're out of here. Right? For the rest of the week, most of you are out of here. So get it to me either tomorrow or Wednesday, but then grades are going into math. All right, now pack up and have a great day. Do your work. Do your work. Finger wag, dude.
Do your work, Antonella.